Hello and welcome to the first in a series of videos about RockNSM. It's something we've worked hard on and are excited to increase awareness about it for both security professionals and enthusiasts. Very few of us have time to invest in a video that's 20 or 30 minutes, even more. With that in mind, it's our goal to respect your time by providing video content that is focused on the bottom line. So what is Rock? Rock is an open source network security monitoring, or NSM, platform that was created by incident responders to solve some difficult problems. After many real-world missions and exercises, it was clear that there had to be a better way to conduct NSM operations, and Rock was born out of that need. It was designed with the following core values in mind. Security. A sensor is, and has proven to be, a prime target for the adversary and must be protected. It's a point of entry to so much data that it could be devastating if compromised. That's why the core of Rock is built upon a proven platform, CentOS 7, with SE Linux enabled. Our experiences in training and response missions have led us to the passive collection model. Why passive, you ask? Number one, it's not your stuff. Network defense responders do not own the network, nor should they want to. You want the day-to-day administrators and engineers who know the ins and outs of their environment to be the ones making changes. And secondly, you don't want to tip your hand. The addition of anything new to the environment can indicate to the adversary that an incident response has been initiated. The Unix philosophy for systems to be simple, clear, and modular is important to us. Rock aims to provide only what you need to get things done and throw out all the bloat. Performance. Necessity is the mother of invention, and that was certainly the case early on with the Rock project, as we had to squeeze as much as we could out of what we had to work with. Most organizations don't have unlimited budgets to throw at the latest, greatest hardware, so it's one of our precepts to be efficient with the resources you have to work with. Humans are great at detecting anomalies, and at the end of the day, that's why this tool set exists. We want to enable the mind behind the keyboard to be able to connect the dots as quickly and easily as possible. That's what led us to Kibana, Elasticsearch, and the rest of the Elastic Stack, to make all the things usable and ultimately more observable in order to defend the network. Since Rock is built on top of CentOS, this gives us some advantages in the enterprise. It's quickly adaptable to Red Hat and STIG compliant out of the box. So what's inside? We'll be diving deeper into each of these major components in upcoming videos, but let's have a quick look at what makes up Rock, starting with the three main sources of data: Suricata, Google Stenographer, and Bro. Stenographer gives us full packet capture, high-performance network-to-disk logging, and Stenographer manages disk space as it goes. Suricata is a traditional signature-based IDS that provides us alerts on known bad. Another popular IDS, Snort, can also be used with some configuration. Bro is a network analysis framework that reads and profiles traffic as it's seen. This metadata is then written to plain text, searchable logs. These logs are separated by protocols and activity types such as HTTP, DNS, and SMTP. Bro is also a Turing-complete scripting language, so it's very flexible and customizable. A good example of this is that Bro scripts can be written to extract files based on user-defined alerting conditions. Once files like these have been saved, they can be analyzed using the File Scanning Framework, or FSF. FSF can recursively deconstruct files down to their most basic components, and then pattern matched using Yara to classify and identify what is found. This can provide valuable forensic information and atomic indicators. We have all this incoming data, so how do we balance the load? Enter Kafka. Kafka is a fast message queue that gives us the ability to scale, a highly reliable write to disk, and makes the data available to the Elastic Stack. The Elastic Stack is incredibly diverse in its potential use cases, and the information security space is a great example. All the previously mentioned data flows into Kibana, the front-end web UI, so analysts can carve through the data by using dashboards, graphs, and more. Thanks for watching this quick overview of RockNSM. It's available for download on GitHub, so please come take a look. Also, consider subscribing and stay tuned for more videos, where we'll be covering each piece of the architecture in depth and how they work together. Thanks.